the equation in the x direction. Let me get a question. I just wanted to show you that we have three forces at points D plus one force at the support, so it doesn't really matter. So it's known. And then we have two unknown. Cool. Okay. Okay, so we write the equation in the y direction, in the x direction, and we just have two forces in the x direction. So we already know what FBD is. It's minus 6.8. So we write it here, and then we have FDE as the unknown, and we get this. So now we can say, now you tell me, DE and BD, tension or compression? Any ideas? So we had this FBD and we got negative. So this is the force acting on BD. And for FDE, we got positive. So we get this. So this is in compression and this one is in tension. Any questions? Okay. All right. So now that we know D, we can move to joint E. We know the force in the DE member DE, and we only have two variables. So FDE is 6 kips to the left, according to the previous results. And so we write the equation in the y direction, and we get FBE. Yeah, so FBE would the y direction would give you FBE, and you have to write this for the x direction. Okay, we have to add this here. Add minus 6 plus F. So now EF is in tension. So we solved for A, D, E, and we don't need to write the equations for joint B because we already know DB, we know AB, and we just got BE here, and these two are actually symmetrical. So BC and AB are equal, these two are equal, and we already solved it. So let's go, if there's no question, let's go to the problem of zero force members. So for this loading, we want to determine the zero force member in this truss. And I would just remind you briefly that if we have joints with two members, so generally we could have special conditions at some joints. So one example is a joint with two members that are not parallel. So in this case, both are zero force members. And we have another case where at joint O, we have two members on a straight line and another member. So in this case, this force would be zero. So according to these two cases here, we can actually solve many zero force members in trusses. So let's talk about this problem here. We have to find a joint that look like these. So if you look closely, you can find them here. For example, at joint G, you have three members, two of them are on the straight line. So we can say DG is a zero force member. Then I also have a JY here, FY and FX. You should always consider the reaction forces first before going through the problem. So here we only have vertical external forces. So Fx is actually 0. So if this Fx is 0, then at joint F, I have two forces, Fy and AF on the straight line, and I get Fg in the other direction. So this is also a three force member. So this would be 0. So if this Fg is 0, then GH is 0. So now we have to look for other joints. So if you look at joint D, you see that it is also a a joint with three forces. It's because DG is 0 and AD and DH are on the straight line, so DB is 0. So this is a way that you should follow to find all the zero force members. So at joint J, you have IJ 0, then you go to joint I, then HI is 0. And what else? So um, I guess we found them all, right? Any other joints? Any ideas or any questions? Okay, so let's see. We got similar results, right? Yeah. Okay, so let's go to another problem here. We want to use the method of sections to derive the forces at members DF, EF, and EG. So these are the three members. I'm sorry, it's not DE, DF. So in questions that are asking for specific members, the best method is to use the method of sections, because you don't need to solve for all the members in the trust. There's just some particular members, so you can use probably the method of sections. So especially in this problems like this, that you have many joints, I don't know, maybe more than 10 joints, it would be very tiresome to solve for all the joints here. So we have to find a suitable section. So here that it's kind of obvious, because we want DF, EF, and EG. So the section is this, and so you can go on and solve the question. It could be a good practice for your homework. And then we get back to the solution. Okay, so let's see. Any progress? Any questions? We have 3 variables here. So in that section, we have f, df, fef, and feg, so 3 variables. And we have to derive the reaction forces first. So because we have 2 forces in the same direction, in same magnitude and opposite directions. So we actually don't have any AX. And we also, if you write the moments about point A, then you realize that ny is 0, and therefore we don't have any vertical reaction at point A. So we don't have any reaction forces. So AY and AX are 0. So we just have this 16 kilonewton external force at point A. And at this point, you just have to write the equilibrium equation for this free body diagram. So we can actually pick point E here. This is a good choice. And then write the moment about point E. Because we have 2 unknown forces passing through point E, we would just have 1 unknown, which is FDF in this case. And we can easily solve the equation for just 1 unknown. So this 16 kilonewton has 6 meter distance from point E. So this is the moment of this external force. Then FDF in the x direction passes through point E, so there's no contribution. So we just have the contribution of the y component of this force. So FDF times 3/5 would give you the y component. And because it is clockwise, we have a minus sign here. And so then we can get FDF equal to 40 kilonewton. Any questions? It's up to you which point you take to calculate the moment, or sometimes it's even better to just write sigma fx or sigma fy. It depends on the case. But in the method of section, because most of the time you have 3 variables, you have to write the moment equation at the end. So just need to look at the geometry and find a good point. So now we could actually change our coordinate system such that one axis lie on the direction AE and the other one perpendicular. So let's call this y prime, x prime. So this is actually sigma f in the y prime direction. Because in the y prime direction, we don't have any contribution of FEG and FDF. And we can again solve just for 1 unknown. So FEF cosine of beta This is the angle with line AE, and if you want to know the angle, you should know that this beta is actually equal to this angle here, and you can actually write the cosine as the cosine of this angle at point A. I have to go back to the, so here we get 12 in this direction and 9 in this direction, and this is actually beta. So I'm considering this triangle. So that's why I can write cosine of beta equal to 12 over am I right? Oh, I'm sorry. So this is actually, so 12, 9 is 3, 4, 5. So cosine is 3 over 5. Is that clear? Alternatively, you could write sigma Fy equal to 0 and sigma Fx and write two equations with two unknowns. But you can always try to find the best coordinates. So in this coordinate, you just have FEF. That's why we chose that. And finally, we get 12 kilonewton for FEF. Now I can pick point F. I have two of the forces passing through point F. So I just have 16 kilonewton external force and this FEG. And I simply write the moment about point F. Both are counterclockwise, so we have both positive. So I'm going to, do you have any questions about this problem? Okay, so I'll have another discussion session on Thursday after your midterm exam to make you ready for your homeworks, which is due Friday. So does anyone have any problem with Thursday morning at 11? Anyway, I'll send you an email and ask everybody about that. But in case if you have trouble with that time on Thursday, I can probably change the time. Okay, thank you everybody.